Now that we've learned about congruent triangles and how we can use them to prove other things as well, we are going to apply them to a new topic, which is isosceles and equilateral triangles. However, before we can actually start that, we need to know some things about isosceles and equilateral triangles and give us some definitions that we can work off of. So we're going to look at some definitions here, and then we'll also talk about some properties that exist as well. Here are my definitions. These pertain to isosceles triangles, and maybe before I actually talk about these, I should remind us what an isosceles triangle is. So it's worth noting that an isosceles triangle is just a triangle that has two sides congruent. And on top of that, I guess a better definition, the definition we used before, was that it has at least two sides congruent. And the reason that's important is that an equilateral triangle, where all the sides are congruent, is also a type of isosceles triangle. And so that's important to keep in mind here. And it's going to change how we think about a few of these definitions are actually here on the page. So the first thing we need to define are what the legs of a triangle are. So the legs of an isosceles triangle would be the congruent sides of the isosceles triangle. So in this case, these two sides here are the legs of the triangle. And then actually I'm going to jump down to that other side, that third side of the isosceles triangle. This is called the base. And so the reason this is interesting for an equilateral triangle then is, well, which one is which ones are the legs and which ones are the base. And so we'll actually kind of refer to all the different sides as either legs or bases, depending on what we're trying to work with. And so, for example, if I want to talk about sides EF and DE being congruent, I'll probably refer to them as legs and then refer to DF as the base in that context. However, if I want to talk about sides EF and DF being congruent to each other, I'll refer to them as the legs and then DE as the base. And so it's all kind of interchangeable. However, when I have an isosceles triangle that just has exactly two sides congruent, the two congruent sides are my legs, and then the non-congruent side would be my base. They can also name these angles. The included angles would be included angle is the angle that's included between. I said include angle. The vertex angle is the angle that's included between the two legs of the isosceles triangle. So in this case, this would be my vertex angle here. Vertex angle. And then my other two angles, the angles that the base is included between, is these are the base angles. And so again, when I talk about these in terms of equilateral triangle, I can use them interchangeably depending on what the context is. And so each of these is a vertex angle, and each of these is a base angle depending on which sides I'm referring to. So these are all the definitions of parts of my isosceles triangle. The other thing I want to talk about and spend a little time with is what are some characteristics. And we're actually going to end up proving these later on, but it's worth noting before we actually get to that point. So if I have an isosceles triangle, isosceles triangle with two sides congruent to each other, it'll be the case, I don't like where those are placed, it'll be the case that there's this symmetry going on here. And so what's actually going to end up being the case is that everything on this side of my triangle is going to be congruent to everything on this side of my triangle, which includes the fact that my base angles will be congruent to each other. And so the interesting thing is that the converse of this is actually true as well, which is that if I have a triangle where there are two angles congruent to each other, what that means is that then the two sides across from those angles have to be congruent as well. So if, and this is something that we'll prove, if I have an isosceles triangle, the angles across from the legs, the two base angles, will be congruent, or if I have a triangle with two angles congruent, the sides across from them will be congruent as well, meaning that it will be isosceles. And I can extend this even further then to say that, well, what if I have an equilateral triangle? And if I have an equilateral triangle where all the sides are congruent, what will end up being the case is, well, if I look at it from a standpoint of this being one of my legs and this being one of my legs, that means that these two angles are congruent to each other. And instead, if I look at it from a context of these two legs here, then these two angles will be congruent to each other. And so I can work my way around, and what I'll end up finding out, and this is maybe an obvious fact, that if a triangle is equilateral, it will also be equiangular. And then the converse of that is true as well, is that if a triangle is equiangular, it will also be equilateral. So these are all things that we'll prove, but will be useful to us whenever we try to solve problems with isosceles or equilateral triangles. And so that'll be the next thing that we do in our talk about congruent triangles.